Our solar system contains a planet that has not yet been discovered. Somewhere far away, so distant from Earth that it cannot be directly observed, lies a mystery that science has been investigating for nearly 100 years. This is the 9th planet, a solid world of ice and rock. It is at least twice the size of Earth and likely about 6 times more massive. Planet 9 orbits the Sun at distances far beyond Neptune and Pluto, reaching up to 500 times the distance between Earth and the Sun. It also follows an orbit tilted by about 16 degrees compared to the other planets. Its orbit is so long that it may take 15,000 years to complete a single revolution around the Sun. Detecting such a large object is extremely difficult. We have fallen into the illusion that we fully understand our own solar system, but in reality, we have only examined it in a superficial way. Now, how do we know something exists when we cannot see it? This is a fair question, and it is actually a crucial part of the scientific method behind some of the most important astronomical discoveries. Everything begins with Uranus, the 7th planet from the Sun. Uranus was first discovered in 1781 by a man named William Herschel, using a telescope he built in his backyard. Herschel was not searching for new planets. He was actually hunting for comets. At first, he thought Uranus was a comet, until it became clear that it was something much larger. This is an example of how a new planet can be discovered by accident. However, this is not a method that can always be repeated. Herschel was not the first person to ever see Uranus. It had appeared on star charts before, but it was rarely observed. It was so faint and moved so slowly that no one had realized what it was. But as scientists continued to track Uranus's orbit, they began to notice something strange. At certain points in its orbit, the planet seemed to speed up or slow down, as if it were being pulled by something. This phenomenon is called a perturbation. It shows that objects in space do not behave strangely on their own. External forces influence them. So what was affecting Uranus? To answer this, we go back to the year 1846. 2 astronomers, Urbain Le Verrier and John Couch Adams, proposed that Uranus's unusual behavior was caused by an undiscovered planet in the outer solar system. Using orbital mechanics and traditional mathematics, they calculated where this mysterious planet might be located. In Germany, another astronomer named Johann Galle decided to point his telescope toward the predicted position. After only a few hours of searching, he observed Neptune, the 8th planet from the Sun, for the first time. After this discovery, people began to believe that using mathematics to find new planets was far more effective than randomly pointing a telescope at the sky. They started searching for more strange deviations, and in this process they found one in Neptune's orbit. A slight wobble was detected. Thus, the search for a 9th planet began. This led to the discovery of Pluto in 1930, which was announced as the 9th planet from the Sun. Here we must introduce a concept called observational bias. Scientists were looking for a new planet beyond Neptune. They found something, therefore it must be a planet. But it was not. Pluto appears large and bright through powerful telescopes because it is highly reflective. In reality, it is very small and does not have enough mass to affect Neptune's orbit. There was no wobble in Neptune's path. It was simply a measurement error. However, this did not end the search for another planet. It only meant astronomers had to work harder to find one. Fast forward to today. Over the last 30 years, many new discoveries have been made in the distant region of the solar system known as the Kuiper Belt. Pluto is located here, but this region is also home to vast numbers of other icy and rocky objects. To give a sense of scale, there are likely thousands of Pluto-sized objects in the Kuiper Belt. We have detected some of them, but most remain undiscovered. In addition, there are more than 100 billion other objects at least 1 kilometer in diameter. The suspected 9th planet would lie far beyond the Kuiper Belt. But if it is out there, we should be able to see the effects of its gravity on distant Kuiper Belt objects. In 2016, 2 astronomers from the California Institute of Technology believed they had found exactly that. Mike Brown and Konstantin Batygin observed a strange group of objects in the outer Kuiper Belt. These objects were clustered in long, tilted orbits that did not resemble randomly distributed paths around the Sun. It looked as if some external force were shaping their trajectories, guiding them into a specific alignment. As more Kuiper Belt objects were discovered, astronomers began noticing these unusual patterns more clearly. They found objects orbiting not around the sun's equatorial plane, but above and below it. They found objects moving in the opposite direction from most other bodies. Just as with the discovery of Neptune, scientists concluded that these strange behaviors must have a single large cause. To test this idea, they ran computer simulations. The early solar system began in a chaotic and disordered state, similar to what it was like when the planets were first forming. They then created two scenarios, one that included Planet 9 and one that did not. When Planet 9 was added to the simulation, all the distant Kuiper Belt objects aligned in exactly the same way we observe today. According to this study, the existence of Planet 9 is possible with a probability of 99.6%. However, the simulation did not explain how such a planet could have formed. There is a massive planet lost far from the Sun. The existence of the Kuiper Belt suggests that there was not enough material in that region to form a full-sized planet. This implies that Planet 9 may have originated elsewhere, possibly in an entirely different solar system. Such an object is called a rogue planet, a world that was ejected from its original star system and now drifts through space. Billions of years ago, our Sun may have captured one of these wandering planets. Another possibility is that Planet 9 formed much closer to the Sun, somewhere between Saturn and Neptune, but was ejected before it could become a gas giant. Because it was not thrown out with enough force, it remained trapped in the Sun's gravitational field. In either case, Planet 9 would consist of a dense mixture of rock, metal, and ice, the core of a planet that never fully formed. If you can imagine something even more dead and frozen than Pluto, that would be it. We are talking about a planet that no one has ever seen. It may seem like we know a great deal about this object, but where is it? Unfortunately, finding Planet 9 will be much harder than finding Neptune. The object we are searching for could be up to 15 times farther away, and because it is smaller and lacks a bright, gas-filled atmosphere, it may be much dimmer. Planet 9 would likely be invisible to all but the largest telescopes on Earth. And even with those, it would still be like searching for a needle in a haystack, assuming Planet 9 actually exists. Remember observational bias. The Caltech astronomers Brown and Battigan were specifically looking for evidence of Planet 9, so they focused on patterns that supported its existence. Could there be other explanations? Absolutely. One potential scenario is even more extreme than a hidden planet. Some have suggested that a small black hole passing through our solar system could be disturbing these orbits. This would involve primordial black holes, objects that may have formed shortly after the Big Bang, when dense clumps of matter collapsed directly into black holes before the first stars existed. If such objects exist, they could be wandering through the universe. Still, it is highly unlikely that one is currently in our solar system. But like Planet 9, this idea has not been proven or disproven. A simpler explanation is that gravity behaves differently at extreme distances from the Sun, and what seems strange to us is actually part of nature's normal behavior. Our understanding of gravity and orbits is based on laws established by Sir Isaac Newton in the 17th century. But Newton could not observe anything beyond Saturn. It is possible that some aspects were missed. Because we can see many nearby objects clearly, we may believe we understand everything about the solar system. Yet as we look farther out, we realize how much we do not know. But soon, we will learn much more. This is the Vera C. Rubin Observatory, the most advanced telescope on Earth. It contains the largest and highest resolution digital camera ever built. It is also equipped with a motorized system that allows it to capture images of the entire night sky every 3 days. Vera Rubin is scheduled to begin operations in the summer of 2025, and its goal is to continuously perform these high-resolution sky surveys for the next 10 years. As a result, we will eventually have a time-lapse video of everything in space. We will not need to search for strange objects. They will reveal themselves in the data. New comets, interstellar objects, near-Earth asteroids, and, if it exists, the ninth planet will be discovered.